Hello, everyone. We'll get started here in just a minute. Just to make sure everyone's in the right place, today's session is Sky API, how it's made in 2024, wonders of Blackbaud engineering system. For today's speaker, we have Paul Gibson. Paul Gibson is the lead architect for donor management, for the donor management pillar within Blackbaud engineering. His responsibilities include Razor's Edge NXT, Blackbaud CRM, Altru, as well as Sky API, and generative AI projects within the Blackbaud platform pillar. Paul has over 30 years of experience building and supporting Blackbaud software systems. And just to keep things in an orderly fashion, we'll be taking questions toward the end. And at this point, I'll hand it over to Paul to begin his presentation.
Okay, thank you, Louis. I'm going to start my PowerPoint deck and then share my screen. Give me just a second to get my windows oriented right so I can still see you guys. And this guy here, okay. And now let me share my screen. Okay. So, hi everybody. Thanks for attending. As Louis mentioned, I would prefer to take questions at the end. I do see some questions in the chat, and I can see the chat. So, when I get to the area where it makes sense to address some of those questions, I will try to talk to them. I see a question already about VPN access to Sky API, so I'll get into that shortly. So the point of this session is it's sort of inspired by that TV show you may have seen on on cable, like the Discovery Channel or something, called How It's Made. Hang on just a second. I'm getting notifications even though I said not to. Let me exit Teams to stop that. Apologize. And in this TV show, if you've ever seen it, they usually take you inside the manufacturing process of sort of everyday objects that you use or consume, like maybe a clock radio or a television or a pack of chewing gum or something. I enjoy watching this show. I always find it fascinating to see all the intricacies and all the people that are involved when one of these devices is made. I sometimes watch it and wonder, like, how does everything not cost $1 million when you see how many people and how much machinery is involved in something like a pack of chewing gum? So as Louis said, I've been at Blackbaud a while, and I work with a variety of systems, and I get to sort of see the behind the scenes of how we build things here at Blackbaud. And like on that show, there's a lot of complexity. There's a lot of moving parts. There's a lot of abstractions. And so I sort of enjoy some of that complexity, and I enjoy sharing it and talking about it. Now, in full disclosure, this is somewhat of a rerun. If you came to last year's BB Dev Days or saw the YouTube video, I did a similar treatment of some of the things. I have some new content for this year. That's why it was labeled 2024. And some of the new content will focus on Blackbaud CRM, which is one of the new products in our ecosystem for Sky API. So there'll be some new content, but it definitely is going to reiterate some of the same concepts that were in the last presentation. So if you don't like reruns, feel free to change the channel. Otherwise, we'll jump right into it. So just like at the start of the show, you frequently see a little teaser of what's gonna happen in the next 30 minutes. Kind of have the same thing. So I'm going to be talking about a component called the Azure Proxy. I'm going to be talking about something called Traffic Manager. We're going to learn about our service authorization service. We're going to learn about something called pods, which is a concept that's somewhat unique to Blackbaud, but inspired by concepts that exist in the industry. We're going to talk about the WAF, or our Web Application Firewall. We're going to talk about another concept that's industry standard, but we heavily utilize it here, called self-contained systems, or SCSs. If you have pods, you're going to need to look them up. So we'll talk about a component called the pod lookup. And then we're going to talk about tenant mapping. So we are, for all of our hosted products, we are in varying degrees of multi-tenancy. And so we frequently have to map various incoming calls, incoming things that are happening to the tenants. And so we have a component called tenant mapping for that. So we've got these are some of the characters, some of the things that we'll see throughout the talk. And so hopefully this will spark your interest and you'll stick with it as we get into these. All right, to start with, I think it's good to level set on the simplicity of the abstraction we've created with Sky API. Sky API is a standard REST HTTP model for how you make web calls. It works with any REST client, whatever your favorite client is, whatever language you use. It's totally standard. And it's really simple. Given a URL, we call that an endpoint, you can make a request from your application and get back the result. Or if it's a post, you can cause the effect to happen. It's a very simple thing. You don't have to know any complexity or whatever. It's very standard. And I always like to say that if you like that simplicity, that view of the world, like you can be fine. You can be at peace. You do not need to know any of the information I'm going to talk about today. So the things I talk about today, I think personally are interesting. I enjoy sharing them. But nothing I say today, I don't believe will help make you a better Sky developer. It won't unlock new capabilities. It won't make you more efficient. It's just hopefully somewhat interesting. So I just want to set expectations for that. This is about sort of like entertainment or infotainment. It's not about how to or to do something better. I will be throughout this talk contrasting a little bit with the classic SOAP API that Blackbaud CRM has had. So Blackbaud CRM has always had an API, and the API was very similar. It used the SOAP API, and the URL was slightly different. But similarly, it was a simple abstraction. You make in this case, SOAP call, which is still a REST call. So really, you could use it once again from any client. It's just the URL was slightly different, and the payloads are slightly different. So again, simple abstraction. You don't have to know all the moving parts. So I thought it'd be good to kind of contrast the classic SOAP API with the Sky API or the new Sky API REST API. At their heart, they're both HTTPS. Personally, I always like to say that I feel like SOAP is REST. It just has a little bit different shape payload, and the verbs are a little more constricted. But there are considered different approaches. If I think about why do we have two ways to accomplish, in my opinion, what's the same thing, I think that the SOAP API came up in a period where it was an era of sort of like post-client server, where the people who had been heavily involved in sort of client server, remote procedure call, they were seeing these new technologies that were merging and these web standards and saying, how can we do the things we've been doing over RPC or remote procedure calls with classic client server programming? How can we use some of these, port 80 and port 443 standard things that are happening with web browsers and have our paradigms work over those? The folks that came from the REST world, which came into vogue about maybe 5 to 10 years later, they came from more of a heritage of like the browser side of things, where like the browser's already got these things. These browser, you type in a URL in your address bar and it fetches it and the verbs get. And when you submit a form that's a post, we've already got everything we need. We don't need to build some abstraction on top of it. So I think they have a different heritage, and that's why they're different. But they have all the same concepts. So in SOAP, you have something called the Web Service Description Language, which is how you do metadata for SOAP. And when REST first came out, there was no metadata language. So for a long, long time, people would say, oh, SOAP is better than REST because I can get IntelliSense or I can have code generators. Well, it didn't take long until that gap was closed. And so now there's Open API and Swagger metadata for REST. And Blackbaud fully embraces this. And if you use Sky API, I definitely encourage you to use code generators against our Open API definitions to facilitate coding in whatever language you use. The other difference is traditionally in SOAP, the payloads are in XML. And for the most part, although this is not necessarily a part of the REST spec, but in practice, most people today use JSON for the payloads. In SOAP, the headers were always in the body, which is kind of funny because in REST, the headers are in headers. So here's one where the REST people kind of maybe roll their eyes and feel like the SOAP people have created things too complex. And in SOAP, there was only one HTTP verb, post. So sometimes if you wanted to get data, you had to get it over a post, which is kind of interesting. Whereas in REST, all the verbs that are part of the HTTP spec are in play. For Blackbaud systems specifically, a SOAP API uses a unique host name per BBCRM database. So every Blackbaud customer is going to start off with some different host name. What's different in our SkyAPI REST API is we have a universal host name URL that's across all customers and in fact across all products in part of the SkyAPI ecosystem. And as we drill into that, we'll sort of see why that's so. And then there's slight differences in how they handle errors. So the key point is that, in my opinion, SOAP and REST are different, but they're equivalent. And we actually can use that to our advantage because when I talk about how we've implemented SkyAPI on top of CRM, we take advantage of this equivalency between the two sort of standards. So when you look at one of these endpoints, for example, an sEdgeNXT, this is the endpoint that's used to fetch data about a constituent. In Blackbaud CRM, there's a similar endpoint, but it's different. And if you're not familiar with Blackbaud systems, we have more than one fundraising system or more than one CRM type system, and they have similar terms like constituent for some of the entities, but they are different. And so we have two different APIs for these different things, for these different products. We're very product oriented in our APIs. We have, over the years, there has often been thoughts and talk about, should we unify these things? Wouldn't it be nice if there was one universal API? And my view on that is we could do that. We could figure out what are the universal consistent things between these. But you always have a challenge when you do that of, are you designing something that's going to have to be least common denominator and make it awkward to do something that maybe is in one product but not the other? So our view is that we want to have the native APIs be close to what the actual product features are, even if they're similar. And then you as a solution developer can always choose to, in your solution, you can have one solution that works with both APIs. In fact, we have things in our marketplace today that are coded to work with both. And it's a little bit of your burden to write the right if statement to know what the product is and to call the right API. But if there is a solution that is applicable generally to some of these common concepts like, constits and addresses and GIFs, it can be done. Just know that those are two different APIs. Here's a view of the same thing for Altru. And if you look at these, you'll notice that there's a lot of similarity in these URLs. So in all cases, the host is always api.sky.blackbaud.com. And the headers that you send up are always going to be the same. So the authorization header with the JOT that you've gotten from the OAuth exchange and your SkyAPI subscription key will always be used with these. What's different is the routes. So let's drill in a little bit and look at this host name, this universal host name for all SkyAPIs, because when we look at this, we'll start to get a clue for what's going on under the hood. So if you do a NS lookup to see how does the DNS name api.sky.blackbaud.com resolve, what you'll see is this non-authoritative answer, very long name that ends with cloudout.net. And if you know anything about Azure, you know that cloudout.net is owned by Microsoft. So that's actually a Microsoft thing. Someone in the chat says that the slides are not following along to my speech. I should be seeing like a DOS looking screen. Are people seeing that on the screen?
Yes, I can see it.
Okay. All right. Well, I apologize. Someone else is having some latency that may be unique to you, but if others are having problems, please chime up. And then I know there were some issues yesterday with some of the tech. These presentations will be available for viewing, recording viewing later. So if you are having tech difficulties, we apologize. And hopefully you can catch back up later and watch them, maybe not live. Okay, so you'll see in these aliases, there's another few keywords in here, things like the trafficmanager.net. So what that's showing you is that on your side, when your DNS resolves api.sky.blackbaud.com, what that's really going to happen is that's going to be resolved to something called the Azure SkyAPI proxy. So in between our system and your application, there's a feature of Microsoft that's designed specifically for these types of things. And what the proxy is, it's sort of like, I like to think of it like a front desk guard. So what the front desk guard does is that component is going to validate that the JOT is valid, meaning it's signed, which means it's a valid OAuth token. It's also going to handle things like throttling. So we're not as concerned about malicious activity, but you can have bugs in your code, and we don't want to have runaway code, some endless loop banging on our system and causing issues for our, production, non-API, just our standard products. So we have some throttling in place. We also validate that you actually have a valid subscription, and some of our APIs require separate subscriptions, like the payments API has a very special subscription you have to have for that. So some of that validation happens there. And then the main thing it does really is routing. So I talked about in the URL, there were 3 different route segments. Well, those are very important keys because those help us route to the exact backend system. So Blackbaud's, our estate is pretty broad. We have lots of products in the skyAPI ecosystem built on different technologies, deployed in different places. We have things like a lot of the education side or K-12 suite is built on Amazon and runs in Amazon data centers. Things like Razor's Edge runs in our own colo as well as in Azure. And so there's a lot of sprawl, basically. And what this API proxy can do is it can help route from a very simple endpoint, that thing I talked about up front, to the right backend. Now, it turns out it's not quite as simple as that. That was not crazy, but we actually have 2 Azure proxies on the planet. And we do this because, one, it's for fault-tolerant reasons, but also, probably more important, is that depending on where you are, the network latency can be quite significant. So, for example, if we have customers that are in Australia region or Asia Pac region, and in those regions, if there was a client application running an Australia data center contacting a Blackbaud customer data in the Australian data center, if that round trip had to come all the way over to the United States and North America and back, even though packets run really quick through these fast networks, it can end up to be several hundred milliseconds of latency. And so we deploy a proxy over in the Asia Pac region. And what that does is if there's an app running in Australia, like even if it's running on, say, Amazon or something, and it's calling a Blackbaud customer who happens to be an Australian customer, and their data and all their systems are in Australia, then all those packets, all that network traffic, even though it flows through the proxy, will stay in that region, and it'll be, tens of milliseconds instead of hundreds of milliseconds of latency. But once you introduce another moving part of having 2 proxies, it begs the question of how do you know which proxy you're supposed to call, right? You could put the burden on the Sky application to say figure it out, but that would mean you wouldn't have that simple single host name I talked about that was this beautiful abstraction. Fortunately, Microsoft has a great feature called Traffic Manager. And what it does is through DNS resolution, it sort of, I like to say, magically takes care of this. So depending on where you are on the planet, when your code says, what is the IP address for api.sky.blackbaud.com, that will actually be resolved by Traffic Manager. And Traffic Manager will know where that query is coming from, and we'll be able to say, oh, well, you're coming from closer to Asia Pac, so I'll send you there, or you're coming from closer to North America, I'll send you there. Okay, so the next topic I want to talk about, I'm going to have to take a moment to describe a term, and then we'll show how the term is used within the skyAPI ecosystem. So self-contained system. What a self-contained system is, this is a logical abstraction. It's something it's been created in the industry, and we've fully embraced this. It came about in the era of microservices. So there was this heyday where people were going nuts and realizing that, hey, we should carve our functionality. We should not have monolithic things. We should carve up our functionality into little discrete services, and every service can be independent, and a team, we'd have a separate team own an independent service. And that was great. And we certainly embraced that microservice heyday. But we realized that if you get too fine-grained, it becomes a little bit hard to manage. So we kind of settled on the concept of self-contained system, which is you take a group of related things, so like little mini parts, but you organize them together and give that a name, and then a team can own that. So it's sort of like a little mini container for complex systems and inner working parts that you can talk about as a single thing. So it's loosely coupled from all other things. There's lots of internal services and data stores that are abstracted behind well-defined interfaces. And these things are built using a variety of tech stacks. So we have SCSs that are built using the .NET framework, talking to Cosmos databases. We have SCSs that are built using Java services that are talking to SQL Server databases, and every mix in between. And the beauty of it is whatever the complexity is local to that SCS. And across SCSs, you usually don't have to know what the details are within that kind of black box component because we use standard interfaces to talk to them. So one of the SCSs that's involved in the SkyAPI ecosystem is something called the Service Authorization Service, or SAS. What this service is it's a database of what services and clients are allowed to talk to other services. So I just described how we have lots of microservices. We want to make sure that there is very strict order to what service is allowed to call another service. So if you think, years ago, maybe 20 years ago in IT, if you had a network, an approach you might take is once you're inside the firewall, any server can talk to any other server. They call it any traffic. That's really not considered a good way to do things these days. These days, you have what's called zero trust. Don't trust anything. So even though it's a Blackbaud system calling another system, we don't want to make it where arbitrary systems can call other systems. We want to have an explicit permission to say, yeah, it makes sense. Does it make sense for this Razor's Edge system to call another Razor's Edge system? Yeah, it does. We want that to be formalized, and that's what the SAS is. So it's a database of allowed service clients to services. This service itself is accessed via REST endpoints from other BB systems. And the way it works is it issues tickets or in the form of JOTs for one SCS to call another one. And it logs that access as well. So we have lots of reasons you'd want to log this. One, we have to do it for compliance. It's just a good idea to have a record that on this day, this service was granted a ticket to that service to call it. So here's how this shows up. So when a call comes in from a Sky application, DNS will be chosen, which proxy it goes to. It'll go to the proxy. And then the proxy can't just call the underlying endpoint directly in the native system. The proxy must first obtain a ticket from the Service Authorization Service. And what that Service Authorization Service will do is it'll issue a ticket, it'll log it, and the Service Authorization Service also has some information that's going to help with routing. Now, when we talk about where it routes to, so let me go back one. On this, I've drawn a simple shape here. BBCRM constituent API is the destination. That is a gross oversimplification. So let me talk about another concept we have to start to peel back the details behind what's really behind that shape. So there's a concept we have called pods. And this is something that, again, there are others in the industry who use this. But what it means for us is we really want to have bulkheads of isolation. So we have lots of customers. We have tens of thousands of customers, or maybe 20,000, 30,000, 40,000 customers. We don't want to have just one pool of an ecosystem that could be subject to catastrophic failure. So if you've ever seen Jurassic Park, you know that even if you have lots of mitigations in place and lots of fail safes and lots of things like that, life finds a way. There can be accidents. There can be things. And so in the interest of having certain bulkheads, we carve up our our customer population into smaller segments. So let's say we have 10,000 Razor's Edge customers. We carve those 10,000 into certain, buckets that we call pods. And then we build infrastructure that's fully isolated in a pod. Like it's depicted here, like a little mini isolated city. And you can imagine if there was some kind of disaster and there was some kind of horrible fire that was happening in one of these globes, it would have no chance of impacting the other globes because it's totally self-contained, nothing is shared. That is exactly the concept with pods. So to make it a little more concrete, when it comes to Razor's Edge, we have currently 8 pods, and these pods live in different data centers. So we have in our Colo data center in Boston, the so-called BO3, we have 2 pods. And anybody who was spun up for Razor's Edge when we were first, came out circa 2015 or so, probably started off in these pods. Now, since that time, we spun up new data centers that are built on Azure infrastructure, and those are in various regions. So S21 is east, S41 is central, S51 is west. I love that we have an Area 51. So I love that certain customers in Area 51. Just I think that's funny. And then we also have international data centers. So S22 is West Europe, S23 is Canada, and S24 is Australia. And these data centers, they share nothing. There's connectivity across them, but all of the infrastructure within them, is not shared. So for example, we could have some sort of catastrophic failure, like in BO3. That is a classic, on-premise data center where we have actual appliances that we lease. So we have, something like a hardware firewall in BO3. Well, if somebody trips over the cable in that, or there's a fire in the data center, or any other bad thing happens, then it's bad for the folks who are in there, but it's not catastrophic to us as a business because there's many other customers in all the other places. And coming soon, we're going to add an S52. So we're growing, and we have a philosophy that we want to minimize risk. So I think our current tolerance is around 5,000 customers per pod. This is for RE, is different for different products. But for RE, I think in S51 or maybe it's 41, we're getting up, 51. I think we're getting close to like 5,000 tenants in there. So we've started the process of spinning up our, whatever that is now, 9th data center for RE. Okay. So now you understand that a customer, and keep in mind, a customer only lives in one pod. This is not a replication type thing. There is replication within pods, which I'll talk about later, but the concept is nothing is shared across them. But that does mean that when a call comes in, that proxy needs to know what pod am I going to call? So there's something called the pod lookup SCS. And what this is it's a database that maps the customer environment to the very specific pod URL. And like with all the other SCSs, it's accessed via a REST endpoint. And it itself is a system that, since another Blackbaud system has to call it implements the SATH authorization protocol as well. So here's what this looks like under the hood. There's if I'm a Blackbaud coder and I'm coding and I need to call the pod lookup, I would use the Swagger page that has this, and this would be the route, and this is the parameters that go into this. It's just standard REST call. So we're starting to get a more accurate view of the complexity here, right? A lot more shapes, a lot more stuff is happening. And I thought to sort of make order of this, I thought it'd be interesting if we had a little animation. So hopefully the Goldcast can keep up with this. What I'm going to do is I'm going to click, and we're going to see this lightning bolt, which is going to kind of represent like tracing a call that's running through the network. So let's see, let it go. It leaves, it goes to traffic manager, it goes to the proxy, SAS, goes back to SAS, goes. Okay, it was a lot of hops and it was a lot of fast. I'm going to do it again, and this time I'm going to try it in slow motion and try to narrate and see if I can keep up with it. So first thing that happens is we resolve our DNS by calling traffic manager. Now we know where we're going. Now we go to the proxy. Now the proxy wants to call pod lookup, but first it has to get a SAS token. So it gets a SAS token to call pod lookup. Now it knows what pod to call. Now it needs to get a SAS token to call that actual pod, and then it calls the pod, and then it all comes back. Now you might think like, wow, that seems like a lot of work and really chatty. I bet things are slow. Obviously, we use a lot of caching in this. So some of that stuff would only happen if everything was completely, the first call after the entire internet rebooted. Yeah, nothing would be in cache, and all that stuff that you just saw would happen. Caching, by the way, is one reason that pods make sense. As much as we like to think that, you can have things that sort of scale infinitely, and I can scale web servers out, there's often shared infrastructure that has some sort of physical limit. So if we had only one pod and we had all 10,000 customers there, and I had some load balancer that was going to, scale out all my web servers, maybe I have 5,000 web servers to handle all that load, I still am going to have the problem of various caching and things like that. I'm going to hit some memory limit. So by introducing pods, you almost introduce like a cache hierarchy as well. And that's one of the other benefits of this. Okay. What I just showed you with those pods was talking about sEdgeNXT. I'll contrast that with a different product. With Blackbaud CRM, that's our enterprise level system. And in that world, we have one pod per customer. So we have far fewer Blackbaud CRM customers, right? We have less than 1,000 Blackbaud CRM customers. And they have, that's a classic on-prem. We support on-premise today, 3-tier system that supports lots of customizations. And obviously in a multi-tenant scenario, we want to be careful about how one customer's customizations impacts another customer. And so what we've chosen is we're using this concept of shared nothing in a pod, and said, well, we'll just put each customer in their own pod. And that way we have consistency because we have ways to script and spin up pods through automation and automated infrastructure, but the customers are completely isolated. So it's going to, when I show how CRM works with SkyPI, it's going to be slightly different, but it does leverage similar concepts. So this is going to be the tracing for Blackbaud CRM. So in this case, I've got a slightly different part over on the back end. I've got a single pod representing a single customer, but I've got this green layer in the middle that says INF translation. That stands for Infinity Translation. And what happens here is we have a single service that is itself the database of what CRM customer is connected to what environment, and what is the URL, and what is the pod for them. And this is a REST call that comes into this translation service. This guy's built on what I'll talk in a minute about our standard engineering system service. All that stuff is REST. You'll see REST, 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 all of our internal stuff. It's called translation because what he does is he turns around and takes those REST calls and reformats them as SOAP calls to call into CRM using the classic existing SOAP API. It's pretty cool. Like the guys who created this were able to move pretty quickly because there's already a pretty broad suite of APIs in CRM. And the only challenge was, how do you translate those into the things that make sense in REST idioms? And so there is a little bit of hand curation that can go into that, but they have a pretty slick system for doing that. And that's why I say, when I say that SOAP and REST are equivalent, this really, the way we've been able to make SkyPI work with CRM really demonstrates that point. It's really just a transformation of one format payload to another format payload. So let's trace this call. So similar, goes to traffic manager, comes in, goes to the same proxy, gets a SaaS call, calls translation, goes through. Okay, now here's a test, maybe in chat. There's actually a missing piece here. Does anyone have a clue? Like I caught myself, I made this slide and I thought, well, that's pretty simple. And then I realized later, like, wait, I left something out. Does anybody see what might be a missing element? I'll give you a hint. It has to do with security topics. Who's validating? Here's the answer. Who's validating between the Infinity Translation is able to call SOAP? Well, that needs to be validated. Well, how does this system trust that this is truly the caller? So there's actually another moving part here. What happens is the translation service must obtain a tick. Good answer, Wadi. So the Infinity Translation Service must attain a SaaS token first. And if anybody's a CRM customer, you may know that we've said, like, you have to be a certain version of CRM in order to support SkyPI. Well, it's because that version of CRM was updated to support recognizing the SaaS token and validating the SaaS token. And that's why there was a certain service pack level that's the minimum to support this. So once you throw that in the mix, you can see how, it's a little bit more complicated, very similar to the pattern with RE, just slightly different about what happens in the terminal state here. So if we trace this, we go to traffic manager, go to the proxy, get SaaS, call the translation calls it. And essentially you can see every time you do a hop from one service to another service, you're going to have to get a SaaS token. Those SaaS tokens, again, are cached, so it's not going to happen on every call. Okay, so we're starting to draw more shapes, starting to get more complicated in our diagram. I'm starting to run out of real estate on my slides, but we're not done yet. There's another moving part involved in all this. I mentioned security. I would have probably also accepted as an answer WAF as a missing part on the diagram. So this is a very standard thing in applications, web application firewall. It's the concept that you put something in between remote traffic coming in from the general internet into your own stuff, and you want it at the perimeter. And there's lots of choices here. There's appliances that do this. There's services, cloud services that do this. And the biggest value they provide is they block known bad IP addresses, right? So there's, these security vendors keep track of certain machines maybe that have been compromised. Could be running on your desk right now. Maybe your home computer got compromised and somebody's mining Bitcoin and it's enlisted in a bot farm and doing bad things. Well, at some point those pop up on a radar, and the security vendors know those are bad IP addresses. They put them in a database, and then their products know to just block those. And then the other things they do is they actually inspect the HTTP traffic. So there are some popular, well-known hacks, some pitfalls, like coding vulnerabilities that are common mistakes people make. A common one is something called SQL injection, where if you're not careful with how you write your application, somebody can supply data in what looks like an innocuous call, but put a semicolon on it and then say select star from table and maybe get data they're not supposed to. Well, these WAFs tend to inspect that traffic and would see that pattern. Only by source from Java use file. I don't get that. Is that a game reference? So, yeah. Okay. So this WAF sits between basically anything, any Blackbaud system, we've got a WAF sitting in front of it. But we deploy that WAF in a couple of different ways. And this is an opportunity for me to talk about something called the engineering system. And this is sort of new. It's not something we've shared publicly too much. So several years ago, we realized that we had a lot of sprawl. Every product was solving a lot of the topics I've talked about pod and isolation and just general software development in the modern cloud era. We were all solving it, but kind of in boutique ways. We were very, very balkanized in how we did things. And we realized, like, we're solving the same problems. Let's have consistency. Let's have a single system. And so we've been converging over time into what we call the engineering system, which is something that's sort of like cloud native in the cloud era. And more products are definitely, as we build new features, we build them on the engineering system. We don't necessarily migrate existing things right away because, if it ain't broke, don't fix it. But over a long period of time, if we're going to do major renovations or change something up. So you'll start to see this in things like the CRM Sky API stuff. All of the new Sky API stuff for CRM is built on the engineering system, but it talks to the native, original classic IaaS system, as I just depicted. Similar with RE, a lot of the new APIs that are coming online, like for the query API, all of that was built in really the query experience in the product itself was built on the engineering system. But oftentimes the entire solution is hybrid. So let me contrast these modern engineering system services with sort of the classic services. So the modern engineering systems or services are what's called cloud native, meaning they were born in this era when cloud providers and cloud services from places like Amazon and Microsoft were just, new technologies that didn't exist. There were not ways to do this 10 years ago. Whereas our classic services sort of evolved from, even going back 20 years when you had classic 3-tier applications. I'm going to have a web server. I'm going to have a load balancer. I'm going to have a classic SQL Server database or classic Oracle database. They're just different eras of technology. These cloud native things have built into them the cloud scale concept. So Cosmos DB has this whole very elaborate system around partitioning. It's almost like they've built in the concepts of pods into their native stuff. So we don't have to homebrew that anymore. It's just built in. Whereas the classic IaaS stuff was traditional database management systems, which if you want to run those at scale and you want to run those at multi-tenant, there's quite a bit of chores you have to do. If you're a classic SQL Server shop running on a corporate, scenario where you just have one database, SQL Server is great at that, does it amazing. Once you try to take that multi-tenant and do it at cloud scale, you got a lot of burdens. And these new cloud scale data stores have, the products themselves embody all those things, so we don't have to home roll it. We've also changed our CI/CD pipelines. We used to have a lot of homegrown pipelines where we had lots of scripts and lots of things. And now there's just products that make that commodity. We run in Azure Kubernetes clusters. So getting into Kubernetes is beyond the scope of this, but just know that that's a modern deployment strategy for running microservices. And classically, it would have been Windows virtual machines. In our modern engineering services, we support Java and .NET Core only, so only sort of the latest versions of these. In our classic services, we were supporting .NET Framework and Core. As I said, a lot of ways the pod concept is obsolete, whereas in classic IaaS services, it was very important because some of these notions just weren't inherent, built into the technology, and we had to roll our own. And another difference is in our engineering system services, while we don't have pods, we do have to still care about regions, which is interesting because we had to come up with a new term for that. And we start running out of terms for some of these things. So zones is our way of handling regions. And in the classic IS services, pods and regions were kind of intertwined. As you saw when I showed that RE slide where S51 was West US or whatever, we kind of commingled those. We realized like we needed to separate those things out. So if I start to get all this tech on the screen, it gets quite a bit more complicated. And I'm choosing to orient this around the WAF because I wanted to show that we use two different strategies for the WAF. For our classic VMs, we actually use a cloud-based WAF. So this is where we basically set the DNS entry where the proxy is going to talk to the vendor's hardware running that's providing the cloud WAF service to us, and then they will route and proxy on through to our stuff. That's different for engineering system services. For engineering system services, we actually run a container of the WAF implementation within our AKS cluster. Frankly, it's more efficient because, as you can see, you've got less of a network hop here. It's closer. And so it is more desirable, but it's just not something we can do all the time. And there's various trade-offs. So we have to make different choices. We do use the same vendor for this, and there is a single pane of glass. So like our security team has a single pane of glass to manage all this. So just because we deploy in different ways doesn't mean you don't have a centralized management plane for all of these things. I'm going to pause here and talk a little bit about one of the questions I saw right out the gate. Somebody asked, if I've got a VPN and I'm running on premise, how am I going to work with SkyPI? And this is unique to Blackbaud CRM. That's the one product we have where customers actually run a CRM instance on their own data center, or what we call on premise. So this is a good spot to talk about that. If you think about how do we pull this off, as you can see, there's lots of proxy layers, and I talked about routing. Your on premise, in a way, is like its own pod. So it's very easy conceptually to say, like, how does all this magic work for on premise? Well, we just treat you as another pod. And as long as we have an entry in our database, in our cloud lookup database, in that INF translation service to say, oh, well, here's the URL for your pod, then it all works. And obviously, what that's going to require is that from our INF translation service, we can call into yours. So if you've got firewall rules or a VPN, then we've got to figure out how are you going to know to let our call in. So there could be different strategies for that. We do have the ability to get static IP addresses and share those with you, and you can poke a hole through a firewall for those. I talked to a customer this week on this very topic, and they were contemplating creating a proxy layer because they didn't want to necessarily poke a hole in their current VPN, but they were comfortable introducing another middleman. And in that scenario, it's very similar to what we're actually doing. It's not different from what we have with our cloud WAF. You would have some either appliance or some cloud vendor that would be the thing that you publish the URL for our proxy to talk to, and then you would have that thing configured to use your VPN to talk to yours. So without getting too, everybody's details are separate. Just know that there are avenues to do that. And if you work with your customer success manager, we can hopefully get you details on some of the options that are available, as we've done with other customers. Okay, and once again, my picture was not as simple as it should be on the last picture because there are different zones. So I mentioned the pod stuff for RE. In the engineering system, we don't have to have pods for fault tolerant stuff because that's sort of built into these things. Like AKS has its own sort of notion, and unfortunately, some terminology overlap. There's an AKS pod, which is different from our pod, but we do still have regional concerns. And so we have different regions, and we deploy AKS clusters into those regions. So we have a European zone, a Canadian zone, an Australian zone, and a USA zone. And we have a few services that are centralized in USA, like pod lookup and SAS. But then usually anything that touches the client data is in that zone. And that way we have this ideal I talked about where if you're a customer in Australia, an application in Australia, all that network traffic is going to stay over in that zone. And we don't have to worry about the global latencies that can creep in. Okay, so we're coming up on time, but let me rush through this lightning round, just because I think it's interesting. So far, there's been a lot of shapes on the screen, a lot of complexity, but we haven't even drilled into a pod yet. So let's see if we can do a lightning round in a pod. So I talked about microservices. In RE, there are lots and lots and lots of independent services. We break up all the services by domain. So there's a constituent API, there's an events API, there's a gift API. And for a given RE database, there'd be a database within that pod. If you think about it, we've got lots of pods I talked about, lots of services. you can imagine that's quite a matrix of things. So we have some internal tooling that is meant to show all of these different services and what their status is. So this is a screenshot of one of our internal tools that shows sort of the matrix of for every pod, what version is what every service on. If we trace an intrapod, let's say we've done all that stuff I've shown before with the lightning bolt. And once we get in the pod, we have a traditional, for REIS services, there's a traditional setup where there's a DMZ, where the constituent API is outside the or is in the DMZ, and then there's an internal subnet, and there's a service which talks to the SQL database. So to be clear, the SQL database is not on the internet. You can't get to this thing from anywhere, which means that to make a call, you come through the DMZ, you call this data service, and there's two microservices involved here. There's a security authorization service which validates permissions. Now, I depicted that previously, that database is one shape, but in reality, we use SQL clusters. So we always have a primary and secondary. We do that for high availability and disaster recovery, and we're multi-tenant. So we'll put around 200 tenants per cluster. And these are very expensive machines. We use solid state disk, very high density. So really, if I was going to draw that picture before, I really needed to put like 200, a handful of different SQL clusters, 200 tenants per cluster. And of course, we have multiple SQL clusters per pod. Because as I said, we might put 5,000 customers in a pod. And if I'm only going to put 200 customers on a cluster, you can do the math, meaning we're going to have lots of clusters. So we have lots of clusters across lots of pods, lots of moving parts going on. Which means when these calls come in, I've got to have some way to track for a given service, what SQL cluster am I going to call? And so we have another service called the tenant mapping service. And this is a database for any given customer, what cluster are they on? And each one of these tenant mapping services only knows about its own pod. So a given database will only have up to 5,000 rows in it because a pod only has up to 5,000. And the higher order routing that I talked about earlier is how we know which tenant mapping service to call in the first place, if that makes sense. So now if we trace this guy, it's pretty complex. Lots of calls. Again, a lot of caching. So every one of those calls won't happen on every call, but on a reboot of all these services, you could see something like that. So there's an aspect of, your mileage may vary on any given call. If you're ever testing latencies, I definitely would say make sure you test 2 or 3 times to get a good picture, because you could be getting caching issues. Okay, and just to show a little bit of how everything I've shown so far is like super high level and vastly incomplete. Here's another diagramming showing that in RE, it's actually a hybrid setup where we've got some services in the engineering system and some in classic services, and there's communication back and forth. In fact, it's quite complex. The new query feature and the new query API, I went and grabbed one of our actual technical documents that we use internally to show the sequence status of all the things that are happening. So imagine this is just one of those shapes I put up. If you were to drill into those to try and depict what's going on, you need a very elaborate sequence diagram like this to show that. So in conclusion, when you're working with this stuff, you can choose your mental model. You can say, hey, I have a URL and I call it using my favorite REST client. And to my view of the world, this is how things work, and it just works. Or you can say, oh yeah, there's some vast machinery that's complicated and has all these moving parts behind the scenes pulling this off. And maybe that's interesting to you, but you don't need to know that. Okay, so that's my presentation, my canned presentation. I know we're right at time. I'm happy to stay a little bit longer and answer questions if there are some, and it'll take me a moment to read what's in the chat. So if you've already asked a question in chat and it still hasn't been answered, please raise your hand again or ask it again, or I'll or just, I think if you can come on and ask the question, that's fine too.
I found one question here. It's related. Looks like it's, and forgive me, I'm pronouncing this wrong. Wadi. Follow-up question: do you take on the WAF responsibility when it's taken to an on-prem CRM pod?
Yeah, good question. Yeah, so I'm going to say we don't take on the responsibility for that hop to the client's on-premise pod. We'll have that WAF in front of that INF translation service. So in terms of anything that's flowing through Sky API, there's gonna be one crack of WAF at it already. However, you're gonna have your endpoint, your pods, your pod endpoint, your CRM instance will be on the internet if it's not already, and it would be wise to have a WAF in place on your side for even if it's not coming from our stuff. So I would say, the customer who's got if customer's running on premise and they have a web server exposed to the internet, they should have a responsibility to have appropriate security measures in place. And WAF is often something that people choose to put in place.
I don't see any more questions here.
Okay.
So for those of you that are still here, please take a second to complete the survey. The speaker that gets the most votes. Oh, wait a minute. There is one question that just came up from Nancy. What are options to WAF?
Yeah, there's Rich. So if you're on premise, and I had this discussion with the customer this week, so it's a little top of mind. There are no end to WAF vendors out there. So if you're, your technology group and what makes sense for you is going to be highly dependent on, your current situation. It could be you have appliances already in place that do this. It's sort of like asking, what's a good phone charger, or something like. There's just no end to the choices you have for this. There are vendors that have cloud services where you don't have to install any hardware and you just update DNS entries and update certificates, and they handle that for you, and it's sort of lightweight on infrastructure. There are physical appliances where you buy a dedicated box and plug it into your rack. There are software appliances where if you're running like a VMware type situation, you can apply the software. And I mentioned containers. We use AKS, so there's container solutions available. So there will be no end to choice to what you have, and I think you just have to work with whoever is your technology provider to pick what makes sense, for your particular network situation. I'll just one more thing. I saw somebody said something about they're in Seattle in S21. Yeah, so in the US, we do not choose regions based on, or where we place customers based on anything regional. Our view is these Microsoft networks we're on are super fast, and we've not been able to detect any difference, in North American traffic latency across these. So we don't make any effort to say, oh, this customer is located in this part of the country, put them in this particular region. In fact, for a long time, S21 was the only Azure data center we had, and Boston was the only one we had. So our strategy around having these different regions is not about location of customer or latency. It's about thinking about that disaster mindset I'm talking about, right? If there is a natural disaster in the US, if there's a tsunami or something and Virginia gets flooded, then hopefully the West US is not also flooded at the same time. So that's when we're placing things around, it's thinking about disaster mitigation, not latency for customers.
Yeah, I don't see anything new in the chat. So if you got a chance, thank you for attending today's session. And before we let you go, if you can, complete the actual survey. Once again, speakers that actually get the most votes will actually be visiting us at BBCon.
Okay, thanks everybody. I'm going to leave the stage.
Take care, everyone.